All right, so we're going to do two together where we find the average value of a function. And again, as I stated, we're going to be using this formula. Bless you. So the average value of our function is 1 over the difference of our limits of integration. They'll give you that. All right, times the value of the integral of our function. Okay? So let's do this first one. I always tell students just the hardest part is to find the integral, that value. And then at the end, all we're going to do is multiply it by 1 over that difference. So let's first write the integral from -1 to 2 of negative x squared plus 2 dx. And if we wanted to find the average value, we would put 1 over 2 minus -1 in front of it. So I'm going to deal with that at the end. Okay? So let's think back to December or Friday. If I see x squared, what am I going? I know it says negative. We'll deal with that in a moment. If I see x squared, what am I going to do if I do the antiderivative? Excellent. So I'm going to put x cubed. Now notice when I take the derivative, I need it to be a -1, so I'm going to have a negative there. And then what do I need in front of that x cubed? So make sure when I multiply, I get just a 1. The reciprocal, 1/3. So if you took the derivative of -1/3 x cubed, you would get -1 x squared. How do you go backwards from 2? Just 2x. All right, do you remember what we did on Friday? Put it in parentheses, put your vertical bar. We're going to evaluate it at 2 and at -1, and we're going to subtract that difference. Yes, we're going to end up evaluating this at 2, evaluating it at -1, and subtract those values. All right, so it's going to be f of 2 minus f of -1. Remember why I used the capital letter F? Do you guys remember why I used that? Because it's the antiderivative. Remember, all right, what did I choose as my C value? 0, very good, right? Always choosing 0. No reason to choose anything but 0 unless they tell you to find your C value. So here we go, -1/3 times 2 cubed plus 2 times 2. So all of that minus -1/3 times 1, -1 cubed plus 2 times -1. What's wrong, Ellen? You just what? Oh, yeah, I know you were opening whatever that was. You're back now, though, so we're good. Okay, what's 2 cubed? 8. So -8/3 plus, what's 2 times 2? 4. So all of that minus -1 cubed is a -1 times a negative. Give you +1/3 plus 2 times -1 is -2. Gosh, I love adding fractions. Here we go. How can I rewrite 4 to have a denominator of 3? So it's going to be 12/3, right? So what's -8/3 plus 12/3? 4/3 minus. How can I rewrite -2 to have a denominator of 3? -6/3, right? So -6/3. What's 1/3 minus 6/3? 1/3 minus 6/3? -5/3. Okay. Now you see how we're subtracting a negative? So really I'm going to do addition. So what's 4/3 plus 5/3? 9/3, which is 3. Now this is not the answer. This is the value for the integral from -1 to 2 of this function. All right, so if it asks for the average value, I need to take this value and divide it across the length of the interval. Or, using your formula, multiply it by 1 over And what is that distance from 2 to negative 1? Well, it's 3, yes. All right, so what is 1/3 times 3? So the answer is 1. You do 1 over the difference in your limits of integration or the difference in your x values here. One more time, Edwin. Find the integral first. That is your value. To find the average value, you divide it over the length of your interval, or if you look at the formula, when you multiply by 1 over that length of the interval, it's the same as dividing by. So it's really like I divided by 3. 3 divided by 3 is 1. So I have found in my only 2 years of experience, but in my 2 years of experience, students use that formula, but they did better if they thought I'm really just taking the total value and dividing it by the length of the interval. Questions on number 1? Okay. Number 2. Same thing. Same setup. So average value is 1 over the distance from 1 to negative 1 times the integral from negative 1 to 1 of 2x squared minus 5x dx. Remember, I always wait until the end to deal with that, 1 over or division. So I'm just going to focus on finding the value for this integral first. If I back up from x squared, I need to write x cubed, right? X cubed. And normally I would tell you to put 1/3, but what is in front of that in front of that x squared right there at the beginning? A 2. So I'm not going to write 1/3. I'm going to write 2/3. Whoa. You're tired of it? We've only done 1. Sure. All right, I'm going to write down x squared. Normally, I would tell students you're going to put 1/2, but there was already a 5, so I'm going to put minus 5/2. Remember, I'm choosing 0 for C, so do your parentheses. And I'm going to evaluate it at 1 and negative 1. All right, so here we go. 2/3. So normally, if this had nothing there, if it was just minus x, it'd be 1/2 x squared. But if I took the derivative of 1/2 x squared, I just could get negative x. So to make sure I get negative 5x, I got to put a 5 in the numerator of that fraction.
The one before, you only put 2x. Like in the one before?
The one before? Oh, because this one is not, it wasn't an x to start. It was a constant. Minus 5/2 times 1 squared. All of that minus 2/3 times negative 1 cubed minus 5/2 times negative 1 squared. How's it going, Georgie? Feeling good? Okay. I like when I get 1s and negative 1s. My favorite one to get in here is a 0, right? Because when it's zeros, it's nice. It just goes away usually. So 1 cubed is going to give me 1. 1 times 2/3 is 2/3. This is going to be minus 5/2 minus. This is actually going to be a negative 1 when you cube it. So that's going to make that negative 2/3. And then minus, this will be a positive 1. So it'll be minus 5/2. Do you want me to do some side work with these fractions? Because I know it can be a lot. Let's do it. Okay, so what common denominator am I going to use for 3 and 2? 6. So that's going to be a 6. What's my new numerator for 2/3 when it becomes over 6? 4/6 minus, what about for 5/2? Right, times 3 gives you 15. Nice. So what's 4/6 minus 15/6? Is it 9? Isn't it negative 11/6? Sorry, negative 11/6. Been watching a lot of Harry Potter, so I'm practicing my parcel tongue. Okay, and then this one, not even a chuckle. Tough crowd today. All right, and then this one is going to be same thing, sixths. So I have negative 4 sixths minus 15 sixths. Okay, so this one. So a negative 4 and a negative 15 is, I heard somebody say negative 19. You're just sitting, Edward. Am I going too fast? George is like, nope, I'm not doing it. All right. It wasn't you? Okay, sorry, Georgie. Take it back. Okay, we're subtracting a negative. Yes, I'm sorry. Go ahead. Okay, cool. Okay, we're subtracting a negative, so it's really adding. So what's negative 11 plus 19? 8 sixths. And you can reduce that to be 4 thirds. Again, is this my answer? No. This is the area under the curve from negative 1 to 1 of this function. So to find the average value of this function, you take this total area and divide it by the value of that length of the interval, which in this case, if I look at negative 1 to 1, that's a distance of 2 units. So you divide it by 2. Or if you use the formula, it's 4 thirds times 1/2. So you're going to get, if you reduce it, you get 2 thirds. This is what you would type in. Okay.